we'll go. Actually, my intention is to complete with the clear gist of the previous one and along with the present concepts. Okay, what do you mean by fractional distillation? We have seen, no? Just now we have seen fractional distillation, and fractional distillation is used by using fractionating column. Here, fractionating column is used to separate different components based on the boiling point. That is simple distillation. This is fractional distillation. Like many components, if you add, also it can be separated. But here, this fractional distillation column is what I just placed here. This only for the separation of two components only. If you want to see the fractional distillating column, actually, it's like a huge big tanker with many outlets to separate different components or different flows present in it. It's a simple fractional distillation column which we use in the laboratory. But in your graduation, at that stage, you are going to do this fractional distillation not at the school levels. But you can see, if you go to the laboratory, you can answer it. Yeah. Any doubts? Yes, children.
Ma'am, can you give me an example of fractional distillation, or can you please explain it with the board?
Which one? Fractional distillation you want me to explain once again? Yeah.
Like by looking at the figure, I am not even understanding. It's so confusing.
No, what you have observed in that video and everything is exactly same. But you want me to explain? Definitely. Definitely. I'll go with this. This is round water flask. But I'll go. And this is a fractionating column. Fractionating column.
Can anyone hear, ma'am? Ma'am, your voice went for like a minute.
Ma'am, I'm also not able to hear you.
Yes, now, leave about the past. Now, at present, is it clear? This is fractionating column. Yes? Here, actually from here, there is a condenser. This is a condenser with two outlets, outlet, and this one is the inlet. Past. Now, is it clear now? You are following it?
Yeah, ma'am, I wanted to ask that thing, that what is the thing that is on some bubbles?
This one. This one is what? This is a fractionating column. These pebbles are used to cool down the hot vapors. It's not like pebbles, some reagent will use it. Okay. So this is the stand. Stand is used to clamp the this funnel is used to hold the funnel like fractionating column. Okay. So here hot fumes will be passed on. Here water. This water will be inlet and outlet of water. This hot water won't mix up with the fumes like hot vapors. It is only used to condense. Like cool down the hot vapor so that you can collect the droplets to the other filter. This is the sample. Yeah? Is it clear? I have shown you the video also. That's why I'm asked to explain it. And this is the thing that exactly what you are showing, observing there. I think it's not too bad. I think.
Ma'am,
Yeah.
actually, the difference between simple distillation and fractional distillation, what I observed is something is kept above that, like the sauce. That
No. It's not about the instrument. Instrument is.
Ma'am, may I say a difference between fractional distillation and simple distillation?
Fractional distillation is used to separate even though there is a less difference between the temperature, we can go with the fractional distillation. By using simple distillation, if there is no gap between the gap is less than 25 degrees Celsius between two samples, we can't opt for simple distillation. We need to go for fractional distillation only.
I understood that is like in this, if one is of like 100 degrees Celsius and the other one if it is 90 degrees Celsius, we could not do the simple distillation, but we can do.
Yes.
Ma'am, can I say one thing?
Yes, dear.
Ma'am, I observed a difference between simple distillation and fractional distillation.
Yeah.
So, ma'am, in simple distillation, you just randomly put the two elements or compounds. I'm not too sure. But in fractional distillation, you actually measure the amount you put.
It's not like that. It's a mixture. Mixture doesn't require any proportion. Keep that in mind. We are just separating the sample. It doesn't require any proportion.
No, ma'am, but like when we do simple distillation, then we just put it randomly. But like if we do a fraction distillation, like how it's written, ethyl alcohol 78 plus water 100.
Okay, this is nothing but it's not a measurement either. It's a boiling point. 78 degrees Celsius.
Oh, ma'am, I thought that was like the amount.
No. Sorry. I think it's my mistake. I did not mention the units over here. So sorry. It's not like that. For example, here see the ethyl alcohol 78 degrees Celsius and chloroform is 61 degrees Celsius. If we have taken these two samples in simple distillation process, we can't separate accurately. Why? Because there is no much difference in the temperature. Understood? So we need to go with fractional distillation only in that sense. Like if there is no much difference in the boiling point, definitely we need to opt for fractional distillation. And simply we can say that fractional distillation is more accurate and sensitive than the simple distillation. I think arranged your doubts. Am I right?
Ma'am, I also wanted to ask one thing that to fractional distillation, if we use a liquid that is more than 25 degrees Celsius and another liquid that is 25, more than 25 degrees Celsius, like in the in the simple distillation. But the steps in the fractional distillation, we could do like that, right?
Yeah, and octet, but simple distillation is used in normal laboratory technique. It doesn't require more accuracy or required temperature or standard everything. The fractional distillation requires all the conditions, much conditions required to do. Yeah, Pragya? What if there is no difference in temperature? If there is no difference in temperature, this is completely mixed up. Even though fractional distillation can much difference is like 10 degrees Celsius also it can accurately separate. But we need to be more alert. We need to observe the temperature in the thermometer. We need to be alert. If it is unknown samples, we can't do anything. If we know the temperature at the particular temperature, we need to keep an eye on the thermometer. It's like constant observation is required. Yeah. Okay, children. I think no doubts regarding this, all the separation techniques with this concept. We have winded up with the separation techniques, but in the next coming session also, I'm going to ask, like half an hour session, we are going with the exercises based on this separation of substances, and then we'll start with the new concept. Yeah? Any doubts? Any doubts?
No doubts.
Okay, thank you. Thank you so much. Okay, shall we log out?
Okay, ma'am. Bye. Good night.
Thank you, ma'am. Have a nice day. Good night. Goodbye.
Thank you.